Good morning everyone. In previous class we discussed about the maximum depth of neutral axis. In this class we discuss about the limiting value of tension steel and moment of resistance. Since the maximum depth of neutral axis is limited, the maximum value of moment of resistance is also limited. So here the maximum value of moment of resistance, that is the mu limit with respect to concrete, or here the value of m limit or mu limit we can write is 0.36 FCK V into Z. Here we know V is the breadth of the section, FCK is the characteristic strength of concrete, and Z is the lever arm strength. So here we put the lever arm value, which is D minus 0.42 into xm. The total formula of the m limit, which is equal to 0.36 FCK B into xm D minus whole into D minus 0.42 xm. And the m limit with respect to steel is also the 0.87 Fy FCK 80 and D minus whole into D minus 0.42 xm. Then we discuss about the limiting moment of resistance value, that is the Newton for mm square value. Here the grade, it is depend upon the grade of concrete and grade of steel. The limiting moment of resistance is here provided for the M20, M25 and M30 grade of concrete, and the grade of steel of which is Fe 250 steel and Fe 450 steel and 500 steel. Here the limiting moment of resistance for the general formula is 0.148 FCK BD square for Fe 250, Fe 450 is for 0.138 FCK BD square, and for Fe 500 the general formula is 0.133 FCK BD square. In the basis of M20 grade concrete, for Fe 250 steel, the value is 2.96 BD square, and for Fe 450 the value is 2.76 BD square, and Fe 500 the value is 2.66 BD square. Then for the M20 concrete, the Fe 250 steel, the value is 3.70 BD square, and Fe 450 steel, the value is 3.45 BD square, and for Fe 500 steel, the value is 3.33 BD square. Same for the M30 grade of concrete, the value of for Fe 250 grade, the value of limiting moment of resistance, that is equal to 4.44 BD square, and the value of moment of resistance for Fe 450 steel, that is equal to 4.14 BD square. For Fe 500 steel, that is equal to 3.99 BD square. So here we put the value of the limiting moment of resistance from the table, which is given in the IS code 456/2000. Only we need to check the value of V and D, then we can define the value of the particular section by easily. When the grade of concrete is not given, or we can assume the value, then we formula the general formulas which is given in the basis of grade of steel. So we can divide the value of those or formulas. Then we can calculate the limiting moment of resistance. Then here we discuss about the two problems. First one is the analysis of a section. Then we discuss about the design of a section. So in this class we discuss about the analysis of section. Then next class we discuss about the design of a section. So first, how can we analyze the section? For underinforced section, the value of x by d is less than xm by d values. What is the x and what is xm? We know here x is the depth of neutral axis and xm is the maximum value of depth of neutral axis. Okay, then for under-reinforced section, the moment of resistance is calculated by the following equation, that is equal to mu is equal to 0.87 Fy into 80 d minus Fy by 80 Fck into V. In code book, the 80 is written as AST. So the formula is also available in code book IS 456 2000 in page number 96. For balance section, the moment of resistance is calculated by the following equation, that is mu is equal to 0.87 Fy into 80 or AST whole into d minus 0.42 xm. And for over-reinforced section, the value of x by d, which is the depth of neutral axis, is limited to limited at xm by d, and the moment of resistance is computed based on concrete. So the formula for the moment of resistance for the over-reinforced section, that is equal to mu is equal to 0.36 Fck to be breadth of the section into xm, maximum depth of neutral axis, whole into d minus 0.42 into xm. So first of all, here we discuss about what is over-reinforced section, what is under-reinforced section, and what is balance section. So before we going through the analysis part, first of all we need to discuss the balance section and under-reinforced section and over-reinforced section. In case of under-reinforced section, the value of tension or the tension force is greater than the compression force. In case of over-reinforced section, the compression force is greater than the tension force, and here in the balance section, the value of the both steel and concrete reach its permeable value at same time. So first of all, in under-reinforced section, we can write here the steel, in case of steel and in case of concrete, the steel reach its permissible value earlier as compared to concrete. So in case of under-reinforced section, we can design a section. So in case of under-reinforced section, the failure chances is less, and it's provide the symptom before failure. But over-reinforced section, the compression force, it means concrete reaches its permeable value earlier as compared to steel. So we cannot assume the section. So in case of over-reinforced section, where over-reinforced section we define, then we need to recheck or decrease the depth of neutral axis value or redesign the structure. So by under-reinforced section and by balance section, we consider the section. So today time is over. In next class we discuss about determine the moment of resistance for the section in figure.